Hi guys, it's Mr. Mustafa here. In this video, we are going to cover some examples on binomial expansion. If you have not subscribed to my video, please like and subscribe for more content. Let us get straight into it, looking at example 1. Example 1 says expand 3a plus 2b to the power 7. Now, the solution for this, S means solution, we know that x plus y to the power n can be written as, the binomial expansion formula can be written as k equals 0 to n choose k, x to the power n minus k, y to the power k. So if we say that x is equal to 3a, y is equal to 2b, and n is equal to 7, and substituting into this formula, we can get 3a plus 2b to the power 7 is equal to k equals 0 to n. N in this case is 7. Should have to the power 7. 7 choose k, x, which is 3a, which is 3a to the power 7, 2b, 7 minus k there, 2b to the power k. Now, expanding this will give us, let me split up all the coefficients. K equals 0 to 7 of 7 choose k, keep on writing n, should be 7 choose k, 3 to the power 7 minus k. By splitting this up, we take the powers, distribute over the powers, a to the power 7 minus k, 2 to the power k, b to the power k. You can see the coefficients are k equals 0 to 7. Coefficients are 7 choose k, 3 to the power 7 minus k, 2 to the power k, and the variable terms are a to the power 7 minus k, b to the power k. Now, we need some 7 choose k, so we need what is 7 choose 0 is the same thing as saying 7 choose 7, which will give us 7 factorial over 0 factorial 7 factorial, which is equal to 1. 7 choose 1 is the same thing as saying 7 choose 6, which will give us 7 factorial over 1 factorial, 6 factorial, which is equal to 7 times 6 factorial over 6 factorial, which is equal to 7. Then 7 choose 2 will be the same thing as saying 7 choose 5. 7 factorial, 2 factorial, 5 factorial, which will be 7 times 6 times 5 factorial over 2 factorial, 5 factorial. 5 factorial cancel out. 7 times 6 is 42 divided by 2. 7 times 6 is 42 divided by 2, which is 21. Then the next one is 7 choose 3, which is the same thing, 7 choose 4, which is equal to 7 factorial over 3 factorial, 4 factorial, which is 7, 6, 5, 4 factorial, 3, 2, 1, 4 factorial, 4 factorial, 4 factorial cancel out, the 6 and the 6 cancel out, 7 times 5, which is equal to 35. And the last one, which is 7 choose 5. Did we do 7 choose 5? Yes. So 7 choose 4. We have done everything. So we have, so what we can write down now is 2a plus 3b. I think it was actually the other way around, 3a plus 2b, sorry. So should be 3a plus 2b is equal 3a plus 2b to the power 7 is equal to, so 7 choose k is equal to 0 in this case. So if k is equal to 0, we got 7 choose 0, which is 1. We're not going to write down the 1. Then we got k as 0, so we will write down 3 to the power 7. 2 to the power 0 is 1. A to the power 7 minus 0, so you can write down a to the power 7, b0, plus the next one should be a to the power 6, b. We just need to figure out the coefficients here. So the coefficient for 3 to the power 7 choose 1 is 7 times 3 to the power 6 times 2 plus 7 choose 2 should give me 21. 3 to the power 5, 2 squared, a5, b squared, plus, let's do one more here. 7 choose 3 should give me 35. 3 to the power 4, 2 to the power 3, a to the power 4, b to the power 3, plus 7 choose 4 is again 35, a to the 35, 1 second, 35, 7 choose 4, 35, 3 to the power 3, 2 to the power 4. We had a4, so we should have a3, b4, plus, then the next one we should have a squared b, a squared b5. Then the next one we should have a, one second, a squared should be a b6, and the last one should just be b7. So what is here for a squared b5? For a squared b5, we're looking at the value of k, which is equal to 5. So 7 choose 5 was 21. 3 squared, 2 to the power 5, a squared b5, plus the next term was for k is equal to 6. So 7 choose 6. 7 choose 6 is 7. 3 to the power 1, 2 to the power 6. And the last one, 7 choose 1 is 1. 3 to the power 0, 2 to the power 7, a to the power 0 bk, so 2 to the power 7, b to the power 7. So final answer, 3 to the power 7 times a to the power 7, so 3 to the power 7. Let's see what we have here. 3 to the power 3, which is 27. 3 to the power 4, which is 81. Let me take 81 times 3. 3 to the power 5 is, say, 81 times 3, we got 243. And then 3 to the power 6 is 243 times 243 times 3, which will give us 729. Then 3 to the power 7 times 3 should give us 2187. So guys, I think we don't need to go that far. We can just write down these answers here. So let us just simplify and simplify as far as possible. So what we can write is 3 to the power 7 a7 plus 7 times 3 to the power 6 times 2. So I'll just write 14 times 3 to the power 6 a to the power 6b plus 21 and 4. We can get 21 times 4, which is 84 times 3 to the power 5 a5b squared plus 35 times 8. Can we do 35 times 8? Yes, we can. 35 times 8, we can say 350 minus 35 times 10, 350 minus 70, we can get 280. 280, 3 to the power 4, a4b cubed plus, next one, we can say 35 times 16. We can actually say 35 times 16. We can write down, we have 280. We can just double that, 560. 560 times 3 cubed, a cubed b4 plus, what we have here is 20. Let me just do 21 times 9. So 21 times 9, we can say 210 minus 21, we will get 189 times 2 to the power 5 a squared b5 plus 21, 7 times 3 is 21, 2 to the power 6 ab6 plus 2 to the power 7 b7. Guys, if you have a calculator, you can just work out all these coefficients, right? So you can leave your answer in this form, right? Let us move on to question 2, example 2. In the expansion of x plus 3y to the power 7, find the value of the coefficient in x squared plus y squared. So we want to know what's the number next to x5 y squared. What's the number next to x5 y squared? So the solution, we know that the terms formula is t k plus 1 is equal to n choose k x to the power n minus k y to the power k. In this case, n is equal to 7. So we can say, remember, k goes from 0 to n. So you actually end up with n plus 1 terms. So solving this, you can say t k plus 1 is equal to 7 choose k x to the power 7 minus k y to the power k. Now we want y squared. Therefore, since we're just comparing this to x5 y squared, right? obviously some block here. So we want y squared, therefore k is equal to 2. Now if k is equal to 2, we can say coefficient in other words, if you expand this in order, you'll see that this will be term 3, which is 7 choose 2 x to the power 5 y squared. So we're just interested in the coefficient. Let's take this out. So coefficient is 7 factorial over 2 factorial 5 factorial, which is equal to 7 times 6 times 5 factorial over 2 factorial 5 factorial. So we're getting 7 times 6, which is 42. Dividing by 2 is giving us 21. So the value of the coefficient is 21. The value of the coefficient is 21. Coefficient of x to the power 5 y squared in the expansion of x plus 3y to the power 7. Moving on to example 3. Example 3 says, find the coefficient of the term that contains x to the power negative 8 in the expansion of this. Right. So solution, we will start off with tk plus 1, which is equal to 8, 8 choose k. Oh, sorry, let me just write down the formula. So you can write down n choose k, the terms formula, n choose k, x to the power n minus k, y to the power k, where n is equal to 8. X is equal to, we should actually use not x, let us use a and b. So we can say this is a and this is b. So where a is equal to 1/3 x and b is equal to 2x to the power minus 3, because that's 2 over x cubed. So k plus 1 is equal to n choose k, which is 8 choose k, which is, that's what we need to determine, a to the power, what is a? A is basically 1/3 x, 1 over 3 x to the power 8 minus k, 2x to the power negative 3 to the power k, b to the power k. Now let us group all the coefficients. Coefficients are this, and group all the variables. So group coefficients and variables separately. That's how you group them. So 8 choose k, 1 over 3 to the power 8 minus k, and then 2 to the power k, into, then the variables are x to the power 8 minus k, x to the power negative 3k. Now, grouping these coefficients are already grouped, but the x's are not grouped. Same basis, we add the exponents. 8 choose k, 1 over 3 to the power 8 minus k, 2 to the power k, into x to the power 8 minus 4k. Now, we want to compare this and we want to find the coefficient. So this here is basically equal to something with x to the power negative 8. So now we can take x to the power negative 8 and equate it to x to the power 8 minus 4k, because the final result needs to be negative 8. Therefore, we can say 8 minus 4k is equal to negative 8, minus 4k is equal to minus 16. Therefore, k is equal to 4. Now, if I substitute k as 4 inside here, I will get negative 8. Therefore, it makes sense to substitute 4 inside this, which determines our coefficient. Now my coefficient is equal to 8 choose 4. Coefficient is equal to 8 choose 4, 1 over 3 to the power 8 minus 4, which is 4, and then 2 to the power 4. Well, I can work this out and this out. Let us look at what's 8 choose 4. So that's 8 factorial over 4 factorial, 4 factorial, which is equal to, take this out because, right, not the entire thing is equal to. So we're just working on 8 choose 4. 8 choose 4 is equal to, so we have 8765 times 4 factorial over 4, 3, 2, 1 times 4 factorial. 4 factorial, 4 factorial cancels out. 3 times 2 is 6, and 6 cancels out. 8 and the 4 cancel out 2 times. So all we have on top is 5 times 7, 35 times 2, which is 70. Therefore, coefficient the coefficient is equal to 70 times 2 to the power 4 is 16 over 3 to the power 4, which is 81. This is 81. Just say, we just write down 81 over 81. Now, it's the coefficient of what? It's the coefficient of x to the power negative 8. That's all we needed to determine. Now, 70 times 16 times 81. Now, 7 are 7 times 16 is 112. So 1120 over 81. That should be your final answer. 1120 over 81. That is your coefficient. Now, let us look at the next example, example 4. Going back to example 3, sorry, skipped it. So coefficient of x to the power negative 8. Find the coefficient of the term that contains x to the power negative 8 in the expansion of. So the coefficient of the term that contains x to the power negative 8 is 1120 over 81. Example 4. The coefficient of x squared in the expansion of k plus 1 over 3 to the power 3x to the power 5 is 30. So solution, looking at the terms formula, tk plus 1 is equal to n choose k, a to the power k, b to the power n minus k. Or you can write it as switch the a and the b around. It's the same thing because of the symmetry of the binomial distribution, the symmetry of the Pascal's triangle to determine the coefficients. Now, we can say that a is equal to k and b is equal to 1 over 3 x, and we know that n is equal to 5. So what we can say here is tk plus 1 is equal to 5 choose k into a is k to the power, okay, we shouldn't have used k there, let us use r as the counter, tr plus 1, because we have two k's in the formula. So tr a to the power r, let me just choose this as, change this to be r as well, n minus r. So I can say r here as well, R as well here. So we can't use K because we have K here. We'll have conflicting scenarios. So K to the power R, B is 1 over 3x to the power 5 minus R. We want to group the coefficients, group coefficients, right, and group the variables together, right? So what we're looking at, they say they're saying that find the value of the constant K. Now remember, K is a constant, so that's fine. That will be part of, so this will be part of the coefficient group because it's a constant. So you can say 5 choose R, K to the power R, and now we have 1 over 3 to the power 5 minus R because we are grouping all the 5 minus R. These makes up your coefficients, and your variables is just x to the power 5 minus R. Now this is your variable. Now they're saying that the question says that it needs to be x squared. So if you have to solve this equation to this equation, if you have to equate these, which is 5 minus R is equal to 2, therefore R is equal to 3. So R is equal to 3. R will be equal to 3 because the coefficient of x squared in the expansion of this is equal to 30. So R has to be equal to 3. Now let us see if we know that this coefficient is already 30 if R is equal to 3. So coefficient is equal to 30 when R is equal to 3. So let us determine when R is equal to 3. So we have 5 choose 3. What is 5 choose 3? 5 choose 3 is 5 factorial over 3 factorial 2 factorial, which is 5 4 times 5 times 4 times 3 factorial over 3 factorial times 2. That and that cancel out. 3 factorial, we got 20 over 2, which is equal to 10. We know this is 10, and also 1 over 3 to the power 5 minus 3, that's 1 over 3 squared. So what we have here is the coefficient is actually equal to, so what we know is the coefficient is equal to 30. So 5 choose 3 is giving us 10 into k to the power 3, k cubed, into 1 over 3 to the power 2, because 5 minus r is equal to 3, is equal to 30. That's what we know. Now we can say 30 divided by 10 is 3. This is k cubed 3 to the power minus 2 exponents. Now we can multiply both sides by 3 to the power minus 2. We will end up with 3 cubed, which is k cubed. Therefore k cubed is equal to, so k cubed is equal to 3 cubed. Therefore k is equal to cube root of 3 cubed, which is equal to 3. This implies k has to be the value 3, right? So if you're looking at this example, back to the question again, the coefficient of x squared in the expansion of k plus 1 over 3 to the power 5 is 30. So what we said was, we started off by using the terms formula and raising it to the power 5, and we extracted the coefficients and the variables. Now the coefficient is already 30, so solving this coefficient here equal to 30 gives us a value of k, which is equal to 3. I hope you understand, guys. Please leave some comments for example 4. Let us look at the next example, which is example 5. In example 5, Question says find the term independent of x. Find the term independent of x. In other words, term contains no x value, no x's. In other words, no variables. Right. So what we are looking for is the constant term. Right. In the expansion of this. So we start off with the term formula tk plus 1. You can use k now. So what we can say is 6 choose k, 2x to the power k, x to the power minus 2, which is 1 over x squared, is x to the power minus 2 to the power 6 minus k. Now, grouping all the coefficients and variables, what's the next step? We group coefficients and group variables. You can go back to example 3 and see what we have done here. Right, so grouping these, we got 6 choose k as my coefficient. Then we got 2 to the power k from this term as my coefficient. From the next term, we have no coefficients here. So my coefficients are grouped here. Now my variables is x to the power k times x to the power minus 12 plus 2k. Raising a power to a power, we multiply them out to get this result. So 6 choose k, 2 to the power k, x to the power minus 12 plus 3k. Now, to get the constant term, we need to have a value x to the power 0. So this needs to be equated to something x to the power 0, because it says independent of x. This term must contain no x value. So no x value means x is equal to, the power must be equal to 0. So what we can say is minus 12 plus 3k is equal to 0. Therefore, 3k is equal to 12. This implies k is equal to 4. Now, all I need to do is take the value of k is equal to 4 and substitute it into my coefficient part, because we want the independent term, or independent of x. In other words, we're looking for the coefficient, or we can say coefficient or independent of x, independent of x, which is equal to 6 choose 4, 2 to the power 4, because the value of k is 4. So 6 choose 4 is equal to 6 factorial, 2 factorial, 4 factorial. So 6, 5, 4 factorial over 2 factorial, 4 factorial. 4 factorial, 4 factorial cancels out. 6 times 5 is 30 divided by 2 is 15. So what we're doing here is, this is 15 times 16. 15 times 16, you should get 256, which is 16 squared, and then subtract a 16, should get 240. 240. That is your final answer. So guys, this is the way to solve it. The long method is expanding this entire thing using Pascal's triangle and figuring it out, right? Thank you. This brings us to the end of examples on binomial expansion. If you do have more examples, please post in the comment below. Thank you. Have a good day.